So as been mentioned by me in the last discussion, Apache Hive data warehouse software. Apache Hive data warehouse software facilitates reading, writing, and managing large datasets residing in distributed storage using SQL. The same sometime before, while talking or discussing about pig, we came across the similar kind of things. Similar kind of things in that time. They are mentioning it clearly here. Apache Hive data warehouse software facilitates. So this is basically, Hive is basically a data warehouse software. And this facilitates reading, writing, and managing large data sets. So in the context of big data, we always use a term called large data sets only. Because your Hadoop is basically meant for large data sets which are relatively less in number than small files which are more in number. Hadoop is basically, it is basically meant for huge files which are less in number. It is not meant for small files which are small files, I mean maybe a 500 MB file, a 200 MB file which are more in number. It is not basically meant for that. A 200 MB file, a 200 MB file hardly consumes two blocks, on a 128 MB block size architecture. So that is where they are mentioning reading, writing, and managing large data sets residing in distributed storage using SQL. Structure can be projected onto data already in storage. The data which you have already in the storage, to that data we can project the structure. That is what they say. The data that you have already in the HDFS, onto that data we project the structure. So if you look at this one, how you have your gun shell, same like you have your Hive shell. I say Hive and press enter. I'll enter into my Hive shell. And we have also discussed about schema on read and schema on write are the two things that we have discussed. Schema on read. The other thing you have schema on write. Schema on read and schema on write. So your traditional RDBMS and all works with this philosophy, schema on write. You define something, and based on what you have defined, while writing the data itself, that is being enforced. If you try to push something other than what is being defined, if you try to push something other than what is being defined, then it is not going to allow you. So, while reading the data, it is guaranteed there will not be any trouble. While reading the data, it has been guaranteed that there will not be any trouble. There will not be any issue at all. So this works fine or this works absolutely good in the case of your uh, traditional RDBMS, but is not that suitable when it comes to your big data environment. That is the reason why we follow schema on read. While loading the data, no schema is being enforced, but while reading the data from the same table, the schema is being enforced. For any reason, if it is not as expected, it tries to convert into the format. If fails to convert, at least it is going to put null. So there will not be any problem while reading the data. So schema is enforced on the data through the structure while reading, not while writing. So for big data environment, we feel for big data environment, we feel schema on read is more appropriate than schema on write. Because while writing the data, if the schema has been enforced, it is going to be very, very expensive. So we have seen very clearly while loading the data set, how quickly it got loaded. Even you have sent a Mary data set to your student table, we agreed. Loading is just nothing but what has happened? Linking this structure, linking the structure with the data set. That's it. If it is a managed table, probably the data set is been physically copied from the location to your table that is inside your warehouse when you create the table. So as the schema has been enforced on reading, not any problem, because you know very well now from the last discussion what has been observed, your MapReduce is going to be used in the background. So because of that, your massive parallelism is also possible here. As a result, reading will not be an expensive thing for me, because the backbone is reading is not expensive, because the backbone is my MapReduce, which is massive parallelism. So reading will be efficient. So if the schema is being enforced while reading, there will not be any trouble. So that is why schema on write has got its own advantage and applicability. Schema on read is also having its own advantage and applicability. So we cannot say which is best here. We only say which is suitable to what. Your schema on write is appropriate to the context of traditional RDBMS, and your schema on read is suitable for your big data environment. So we have noticed when we create a table, what kind of table we got created. Now you see here, um, slow. This is almost like your SQL only, not much different. What commands you run, you execute there the same. Use techies, show tables, describe table or describe student, and describe extended. You see that describe extended student. So the location is this one, user Hive warehouse, and in the techies.db student, the input format, the output format, and this not being a partition table, we don't have any partition keys. Partition keys empty, and this is a managed table. It is the time to talk about managed table and an external table. We have two types of tables in Hive. In Hive, we have two types of tables. Managed table and the other one external table. This is also sometimes called as internal table also. I say this one managed table. When I say this managed table, the immediate question is managed by whom? The immediate question that arises is managed by whom? Who is going to manage? Tell me who is going to manage?
The Hadoop ecosystem.
More specifically, the warehouse. So managed by whom? When your automated environments are going to manage, it means the life cycle is in the control of your warehouse. Then only we say it is managed. I mean, I also need to discuss one more thing, which I have already shown it to you in the last session, but still we are going to see it once again. There is a database by name Metastore here. Metastore here. Use Metastore. Show tables. Select a star from DBS. So we have two databases basically. I don't know whether you noticed that or not here when I did that. How many databases we have here? Select star from DBS. Now here I say show databases. It says default and TechieBees are the two databases. default Hive database. Its location URI is this one. Owner is public. Role type is role. Owner type is. And there is one more database that I created yesterday that is by name TechieBees, whose ID is 206. Whose ID is 206. And its location is also inside my warehouse. So you notice there is a directory been created with that database name and all the tables under that directory that or database. So select star from TBLS. Every table that I create, I think you notice all these tables belongs to the database. All these belongs to the database. That is one, database ID 1. And this one belongs to the database ID 206. That is the student table which I created yesterday. And this is a managed table. Now, when I drop a table, when I drop a table, when I drop a table, the meta store information so when I drop the table information present in the meta store is also updated. I mean that that information has been dropped. Along with that, the data set associated with the table is also removed. So which means the traces of your table you are losing completely. So when the data set associated with that one is also being removed, then chances are there that you permanently lose this one, because we noticed in the last discussion, I don't know whether you have observed that closely or not. Originally, I have my data set present in my /tmp/sandbox, and in that I have something called student data.txt. Student data.txt. When I use load data in path and I specified this one, into table, say for example student. What happened was this data set is been physically moved into this data set is been physically moved into this is been moved. Where it is been moved? It is been moved into my directory. Which directory? Under warehouse. Under warehouse. So this data set is been removed from here. It has been moved into /user /hive/warehouse /techiebs.db/student. Into this directory, this is actually been moved. Now when I say drop table, this directory is been removed. So obviously the data set present inside the directory is also been lost. Neither it is there in the original location nor it is there here, which means the data set is been permanently lost. That is the reason why we will not apply this drop on a managed table whose data set is important to us and we don't want to lose it. Suppose we have a data set here. Observe this one closely, friends. We have a data set. You process this one. You processed this one using your MapReduce. You got some output into a specific location. On this output, if you project the structure using a Hive, you project the structure, and once everything is over, your usage, everything is over, then you drop the table, no problem. Because this is the output produced by processing this data set. Even if this is been lost, no problem. I can run the MapReduce job once again on this data set and produce the data once again, the output once again, no problem for that. I usually prefer to go with a managed table on the data set, which is actually produced by running a MapReduce job in the past. On that kind of data set only, I usually prefer to project the structure and make that structure as a managed table rather than a external table. Because yeah.
So in this example, so you're saying we drop the table. Drop the table means so we are dropping the input file or the output from the MapReduce.
Yes, and also in the meta store, the data has been updated, the information has been updated. Now, drop table student. Show tables. We don't have table at all here. And we go here, select star from TBLS. Earlier it was showing a student, I think you remember, but now in this query that is gone. So your meta information is gone. I'm happy at that, no problem. But if you observe closely, from your warehouse also, that is gone. You go to your user Hive warehouse techiebs.db, in that student directory. That student directory is also gone now. I'll show you this. What has happened? The
So it's now
directories that
student
were
table.
there inside this techiebees.db, that is also gone. Now, your dataset called student data.txt is nowhere available on your HDFS now. It has been permanently lost. So we will not be working with a managed table in this kind of occasion. Now, suppose if I am working on the data that is a produce of my other MapReduce job, then no issue. I hope you are getting the point what I am sharing here. Now I create a table, the same one what we did in the problem is once that session is over, then all that is gone. Will not have that. Work/Hive. Now look at this one. This is an external table. Hive-F. This is how usually you run your SQL, your HQL files. You can run your HQL files like this. Now if we go to this one, here we say show tables, not yet. What is that now? Just now? The table type is external table. The table type is external table. Now I say here, select a star from student. No data is available here. Why there is no data available? Because that location, whatever we specified, in that location there is no data set at all. This is sometimes called as lazy loading also. Where we have given that one, TMP, then you have sandbox, then we have something called, it's an empty directory now. And if I put some data set inside this one, I say here Hadoop FS hyphen copy from local. What is that? Slash u slash home slash cloudera slash work slash datasets, then student data.txt into slash tmp slash sandbox slash student. See here, now it says select star from student. You got the data now. And you also go and see here this directory. Under this directory you see you have something called student and you have your student data.txt. Now if this table is dropped, have a look at that one. Drop a table student. Now show tables. We don't have any table here. You go to your meta store and see there, and here the information is lost. But interesting, this directory is as is. This directory, whatever you are using, slash tmp slash sandbox slash student, and in that your student data.txt remains intact. This kind of table is what we call it to be external table, which is external to your warehouse. You also see its location is also external to your warehouse, not a part of your warehouse. Such kind
Srinivas, I have a
of
question here.
tables we technically call as external tables. Yeah.
So is it like just the metadata is being deleted and the file is remaining in terms of external table?
Exactly. Only metadata is been removed, but the actual data set remains intact. So we need to apply a rational which is required to us. I don't say this is good and that is bad. No. It all depends upon your need. Right? Based on your need, you need to decide with which we need to go ahead.
Srinivas, I have a question again.
Yeah, please.
So performance-wise, like which one?
No difference in terms of performance.
The external and
No, absolutely no difference in terms of, because the background execution is a map reduce for both managed table and the external table. So the performance concept will not come into picture at all because of managed and the internal. Because of the managed and the internal. That is what.
sure.
So can you
So
repeat that?
Srinivas,
How you consider this managed and the internal, the external?
Not didn't get you. Come out again.
How we define this managed or external or
I just use a keyword here, right?
table?
If I don't
Okay.
use this external, by default it is considered to be managed table.
Okay, gotcha.
So I differentiate the managed table and the external table with this keyword only. If I use a term called external, create a table, and instead of we saying, because by default it is managed table, other than managed table, if you want to create, even you can create a temporary table, a table which can exist till that session exists. Once the session is closed, those tables are also being lost. That is good in the case if you are working with certain things, and by the time you close the session, you want all those to be removed, then I happily go with my temporary table. So we have three now. Temporary we didn't see. We'll see that one. We have managed table and the external table. Very clearly and precisely we have in terms of data types or definition or anything. In no way these two are different. Both are exactly, from the similar ground up. Similar ground up, external table and internal table. But what exactly we mean by external is to the warehouse. Managed is by the warehouse. That is what? If you apply those terms, external to what? External to warehouse. And managed by whom? By warehouse. So that concept, if you can keep in the mind. Now you see, the same I create, pointing to the directory. The directory necessarily need not be in existence, whatever you are giving. That location, row format delimited, fields terminated by. I think you understand. Fields terminated by, and after that location. If it is a managed table, we don't give that location because the location is by default inside the warehouse only. So such kind of tables are completely managed by the warehouse, their life cycle, everything. And external tables based on you can specify.
So Srinivas,
Yeah,
I have a question.
please.
So when to use external and when we do not want to use internal then?
That is why there is no thumb rule. There is no thumb rule that we need to go with. What has been mentioned by me here, see, even if the data set is lost, if there is no damage to you, even if the data set associated with the table is been lost, there is no trouble to you, then happily go with the managed table. If you need to retain the data set, even if the table is been lost, then you must go with external table. That the constraint or rule I can tell you. But performance wise and its applicability wise depends on our need, on that context. The context is, even if the data set is lost, no problem. When the data set is lost, you will not have problem. If you are capable of getting that back in some other form, we don't have any trouble. But if when the table is been dropped, if the metadata and the data set is been permanently lost, then as we cannot get it back, we need to be very careful in that. Is that clear?
Yeah.
Srinivas,
Yeah.
adding
Thank you.
Yeah.
a question. Like maybe in some business cases that you might have come across, like what would have been a scenario where you thought like, managed tables are better over external tables, like, where you want to store some.
That is what managed tables are better in the context that the output of some job that you executed, if you are using that output not on the original data set, if you are trying to project the structure on the original data set, for any reason if you drop that table in future, then the data set associated is also being lost. And there is no chance for you to get that anymore because ultimately HDFS is the ultimate here. HDFS, from here also if it is gone forever. Because this is the final storage, right? Preservation. From here also if it is gone, then we will not have traces of that anywhere. You are getting my point?
Yeah.
So in that case, you need to be very careful. So the produce of a MapReduce job, happily you go with the managed table. Along with metadata, even if the data set is lost, no problem. We can rerun the MapReduce job again and produce the data. I will not have much trouble. But if the data set is not available anywhere, accidentally or intentionally when you drop the table, still the data associated should not be relieved. Then I go with my, I think you're getting my point. You're going with your managed table. I mean, sorry, external table. So when you say drop the table, from the metastore, the information is being removed, but still that data set exists. So that is where I am stressing no thumb rule here, because either managed table or external table, when you are querying it, you are using your Hive query language only. And that's going to make use in the background. That's going to make use in the background your MapReduce, which is massive parallelism, and we will not have any trouble. So no difference is going to come with this. So this is important feature of the important aspect of your Hive. That is the reason why I've shown it very practically to you. I mean, you need to actually get that thing done, but I intentionally did for the reason you should get a clear picture. You should have a clarity on that. That is the reason why. So any more questions on this?
Yeah. So what are the limitations of Hive then?
Limitations of Hive in the sense I didn't get.
Compared to SQL?
Limitations, there are many. We cannot say, it all again depends on the version of the Hive that you are using. If you are using the latest version of Hive, it is allowing even to do your, because Hive is originally developed for mass activity, not for precise activity. So Hive is basically meant for, it is not meant for row level inserts, updates, deletes and all. Hive is originally, this I want you to, Hive originally not meant for row level updates or deletes or even inserts. Hive is not basically meant for that. But slowly what they are trying to do is, even row level inserts, update, deletes are possible with the latest Hive, which is expensive process, but still it is possible. They are trying to bring Hive very, very, very close to SQL, but not exactly SQL, because here we don't have this primary key constraints and all those things. If any dependency on such, then you are going to undergo the pain.
How you filter data? Like, I believe there's no where condition in a Hive SQL. How are you going to filter the data using the Hive query?
Filter the data you can do, right? Where, say for example, here I say, select a star from student. You got all 33. 33 rows are there here. I think you noticed here. 33. Same, select a star from student where this is how filtering is going to be done. What is the problem filtering the data?
Oh, this is similar to normal SQL query.
Yeah, very. That is where I'm saying it is same like that is where the statement is being given in the beginning. Makes sense?
Yep. So in the summary, like what are the key points we can make it in our mind, like on the real-time scenario using Hive? Like I see that this is normal, similar to the SQL, RDMS SQL.
Instead of
So
you
what is
working with
the
the MapReduce, it is a layer of abstraction on the top of MapReduce. I can say SQL level of abstraction on the top of MapReduce. That's it. You got the point? SQL level of abstraction on the top of MapReduce. You got the output now. See here, output. C5 was Srinivas, 80, and all that stuff you got.
Yep.
And if you go and see the interesting part here, if you go and see in the manage job, you will be noticing it very clearly that here there is only one task that is running. Oh, no issue.
So for each data set, you need to create a table in Hive. For example, you have a student.txt data set is there, and we need to create a student table in Hive to get the
Yeah,
data
we need
from
to
the data
project
set.
the structure. Yes,
Okay.
we need to do that. You see how many tasks are there inside? For this particular query that I executed, how many tasks are there for this query? It got succeeded. Select star from student where marks greater than 90. That is what I specified. How many tasks are there? Only map tasks.
Only one.
Maybe there may be number of map tasks. Of course, here the data set is a very small data set. Only one split or one block, and that block has been processed with the help of one map task. That is fine. But we don't have reduced phase here. That you need to understand and notice. You got my point. This makes sense to you?
Yeah.
Yeah. Tell me. Yeah, any questions?
Okay, let's say in the real-time scenario, I got a requirement to write a MapReduce job. So definitely, so I'm not choosing a Java, but I'm going to choose like we have option for Pig and Hive. So how, on what basis I'm going to choose like I'm going to write a MapReduce Pig or Hive based on the description of the data set or
Now come out again once again. Or what kind of?
no, I got a requirement to write a MapReduce job, either Pig or Hive. So how I'm going to choose like which one is the best, Pig or Hive?
That
Pig script or
no, that we don't have metrics basically.
okay, both
That
are
is based on
completely
the ratio.
different.
Usually we use Pig for transformations and all, data transformations and all. Usually, I say like that. But if you argue why can't we use for some other thing also, as it is allowing you, then I don't have any answer. That is why, see, if originally all these components are developed by Apache, then we never has got this ambiguity. But
Okay.
originally these are not been developed by Apache. These are developed by the corporations like Facebook and all. So once they developed, they started using it and are comfortable with that. They have given it to Apache for further strengthening. So same point of time we got Pig and Hive from two different Pig from Yahoo and Hive from Facebook. So then the question arises, which is good out of these two? It is not the concept of good. Why they developed it like that is to facilitate their own resources to work comfortably with their existing knowledge rather than upgrading them on Java. That was the reason. That was the reason.
Okay. Yeah.
So that is why there is no, I can say one thing, it all depends on your comfort and the ability to use that one. I say like this. Now what we did here, we also can do it using Pig, which we have noticed. In fact, we worked with the same data set, if you recollect properly.
Yeah, that's what I'm asking. The same database we use Hive
Yeah,
and Pig.
definitely compared to you want to perform ad hoc analysis on your data sets, then Hive is preferable because once structure is been defined, I directly go and run the query. But whereas in that case, what needs to be done? The entire script needs to be executed. Ad hoc querying may not be possible there, either through scripts or you physically go and get those things done.
So normally the BI reporting or like dashboards based on the output. So Hive is a paperable, filtering the
Yes,
data from
yes.
the.
I mean, maybe biased towards that, slightly biased towards that. Because it's easy, right? For you, you can, once everything is here, then I can go and get it easily. I can directly run my queries and all here. I can use this one and get all my things done. So no thumb rule as such, no thumb rule as such. How you are going to get see here, let me take you there. So you don't have anything called now only load being used by us, right? Loading files into tables. That is what we call it to be. Loading files into the table. That is what we call it to be my load data, local or in path, and overwrite in table name, whatever it is. We are very comfortable with that. So we did. If the keyword local is specified, then the load command will look for the file path in the local file system. That's it. If the keyword local is not specified, then I will either use the full URI of file path, if one is specified, or will apply the following rules. What rules? Where you are, if the path is not absolute, then I will interpret it relative to the user and that Cloudera app. Based on that, it is going to see which user has logged in. That is what the path it is going to consider. If override keyword is used, then the contents of the target table will be deleted and replaced by the files referred to by a file path. So that is all clear to us. Now here you see. Now insert overwrite into the table. What is going to happen? That is going to overwrite the existing data. That we are clear. So partitioning we see, don't worry. I want to specially focus on partitioning part, not like this. See here. What it makes? Now we have 33 records, right? Now I say insert into student exactly like your SQL only, right? Any difference? Maybe C10 RAM and marks.
C10 is already there.
No, it will no problem. That is not a unique thing, right? That
Okay.
is class 10. This is a
So
new
it's going to be
name.
overwrite.
See this, what it is doing? That is the reason why I am saying it is expensive. It is expensive. And I'll also show you, don't worry, I'll also show you, taking you to the folder structure. I think this is a managed table, if I'm not, no, external table. External table. Oh, sorry, slash sandbox. And in that we have a student. See how expensive that is, still it is doing. You remember, it is still working to just insert that single record, insert into student values. So there is some staging activity going on temporarily and all that stuff. Have a look at this. Then moving data to that one, all that stuff been done. Now select a star from student. How many we got now? How many we got now? 34. Earlier it was only
34.
that C10. I think you have seen that here, been added here. See that? This newly created file, I think now you understand what is happening when you are inserting and you are doing the data. Though we have multiple files in the background, but when you are querying, it is going to come something like that. See how many practical things we are seeing in the background. Observe here. Truly speaking, you need to do all these things on your own and get your own conclusions. But to make your process easier, I am trying to show all these things so that at least it will give you the confidence. It will boost up your morale. Fine. So many things are clear. There is no ambiguity. Let me try on my own and see how I am going to work with these things. So your row level inserts, row level updates and row level deletes are definitely possible with your Hive, today's Hive. But you have noticed how much expensive that is. You noticed how much expensive that is. A MapReduce job needs to run in the background. Now for that sake only I will take you to manage jobs. In the manage jobs, you can see what is that? Insert into student values. A MapReduce job is running for you in the background. A MapReduce job is running for you in the background. So what tasks are there? Only map tasks. So you understand from this one, when you are inserting the data, only a map task is being executed in the background, not the reduce task. I think it is pretty clear to you. Any questions to me, friends, on this? So your update is also available. Update is available starting in Hive 0.14. Updates can be performed on tables that support ACID. And the standard syntax for that is this one, how you are going to update. And delete is available starting from this one. And this delete from table where you give the condition, based on that it is going to be deleted. So, but even though it is allowing you to perform, I don't encourage you to perform these operations on your table. Though your Hive is allowing you, to perform your row level inserts, updates and deletes, but we don't encourage you to do that because Hive is basically not meant for that, and Hive will not give you the expected performance. You see, you think it takes the same time with your traditional RDBMS to insert the record what you are given now? You think it takes that much time?
No.
It takes more time.
More. But if you see closely, if you want to process a 1 TB data, 1 TB data set with your Hive by executing some query, that will be much faster compared to that of your traditional RDBMS. So for what purpose? Then we need to use in the same, but they're trying their best to make, but this can never, Hive never can be a transactional database. That you need to keep in the mind. Hive can never be a transactional database. What I mean by that? What I mean by that, friends?
Like we don't want to use Hive for data manipulation.
Yeah, we'll not be using Hive definitely for doing your transactional activity. I mean, for banking transactions and all, where millions of transactions in a busy bank, millions of transactions per second happens globally, then we'll not be will lean towards Hive for that kind of transactional activity. I think you are getting the point from where I am coming here, right? So you have any questions on what we discussed? See, the rest of the part is your ability in querying the table that you have created here. You apply all the possible and try to query this one. You're applying where conditions, complex where conditions. Complex where conditions, I mean, where max greater than 50 and signs less than. You can apply whatever the conditions you feel appropriate to that context and see how your data is coming. When you're running a query, what sort of MapReduce phases are functioning for you in the background? Why there is no reduced phase? That visualization you should get automatically. Then you are done almost. Then you are done almost. So can we do like this? Select std comma min of maths comma max of maths from student group by std. So what is the output you expect from this one? What is the output you expect from this one? Friends, are you able to understand?
Is that the minimum of the maths and maximum of the maths based on the group of that standard?
Exactly.
And we're going to see the reducer in the background.
So you look closely here. What is the job that is running now? Select std comma min of max max. Min and max are the built-in functions provided by your Hive. And you see that here. Please don't estimate, friends. Srinivas, the data set having 34 records, this itself is taking this much time. How about the 1 TB data set? No. Here, the common overhead for running any MapReduce job will be there, even with a small or a big data set. That a common activity that exists for every job, that is taking more time here. But when I run against a 1 TB data set or something like, even in that case, you will be getting the output in the same time almost. Not much difference. You got it now? That is why I am encouraging you, friends. Please do experiments, because this is going to be very thrilling also. See, on a data set which is not structured, how we are projecting the structure and trying to retrieve whatever you need through that structure. That is very interesting. And now I will take you to this one and show you physically that when you go to the task here, what is happening, what task been executed in the background.
Map and reduce both.
So what I am saying now is, when you are framing any query, something like this, that time itself you should have the visualization or the imagination that what sort of MapReduce job will be functioning for you in the background to run this query. You should get that visualization. Not you wait till the job is going to finish. You go to the job browser and there you notice, oh, this query has resulted reduced task also. That doesn't make sense. That is what I am insisting you. That is what I am insisting you to get your things done. Right? Do all the possible experiments. Understand clearly what we mean by schema on read and schema on write. Manage table and your external table. What difference exists between these two? So you should have a clarity, and your row level inserts, updates, deletes, how they are happening with your Hive. And why I'm saying that though it is allowed, but I don't encourage you to do that. Why? So all these you should get your own understanding. And then only it makes sense to work with these aspects. And you also need to create a temporary table. Now here, when you are in this, you create a temporary table, and when you exit this one, whether the temporary table exists or not. If it does not exist, or you understand, oh, temporary table is only till this session. Once the session is closed or terminated, then the table is also gone. All that we need to understand by doing experiments. And all these experiments will be only one time. Once you get the confirmation and the clarity, we need not repeat them regularly. At times when it is required, you'll be directly going and attempting them and make them to get executed as expected. Right? So hope this is clear to you, friends, whatever I am discussing.
Srinivas?
Yeah.
One quick question. So in this task, even reducer is working?
Yeah, reducer is working because we have used group by STD. So data is getting grouped based on standard. So as grouping is there, I mean aggregation is there, your reduce task or reduce phase of your MapReduce job is going to exist. That is the reason why we have a reduced task also available.
Oh, I see. Okay. So what is it? It's grouping?
It is grouping based on STD, right? So what is going to happen is all your data all your data is grouped into different groups based on STD. So what is going to happen with this? Let me show you that. So you have how many records in my student data.txt? 34 records.
Yeah.
When I am running a query against 34 records, and I used here group by, the first record I bring, what is a group? What is the standard for that one? Assume if it is C1, I put that in this, the record in this. Okay. Second record I get, if it is C2, I will put here. Third record I get, if it belongs to class 9, then that I keep it in my right here. Fourth record I get, and if it belongs to C8, I write it here. So this has got only the data, that belongs to class 1. You agree with me?
Yeah, yes, Srinivas.
Now this is what we call it to be reducer, one reducer. Of course, in this case, the number of reducers been set to 1, that is why we have got only one reduce task. When you are actually working on a huge data set, I prefer to get this thing done with 10 reducers. Each reducer for one class. So all the data that is of class 1 will be sent to one reducer. That will produce its own output. Then it's going to be more efficient. Now after that, what we are doing in this group, what is the minimum match mark and maximum match mark? So min and max can be performed only on group data. Min and max can be performed only on group data. You cannot perform it on a regular data set. Min of match and max of match means what? It is meaningless, right? We only
Yeah.
bother about the minimum of match and maximum of match within each class. So that is why this min and max functions which are built in expects you to perform group by operation, and then only you want to find the minimum and maximum aspects. Make sense?
Yes, Srinivas, I got it.
So based on the query only, we should be able to decide what sort of execution will happen in the background. No doubt there will be MapReduce job functioning for you in the background. Whether you run a pig script or you run a Hive query, a MapReduce job will be running for you in the background. No doubt. But that MapReduce job, only a map phase will be functioning for you, or a reduce phase also functioning for you. If reduce phase, what sort of aggregation is happening, all that you should get clarity without you looking into the execution explicitly. That is what I am expecting. Here. So the next thing that we see is something called imagine you have a hobby of book collection. You have the hobby of book collection. Wherever you go, you buy at least 1 or 2 books. You bring those books and put it in your shelf. You keep on, keeping your books in the shelf like that. Whenever you buy a new book or get a new book, you just bring it. Wherever there is a space, you put the book there. Something like this. As space is there here, I keep the book here. Issue. If I follow newly added, these are newly added. And over a period of time, this collection went so huge, you have 55,000 books with you. 55,000 books with you in your personal library. You collected so many. And you arranged all these things in multiple shelves. It is something like your private library. Now you want to find some specific book. Then what happens? Are you going to search your entire 55,000? Are you going to search your entire 55,000 to find that specific book? Because you keep on adding, you cannot remember, right, which book you kept where. You think it's possible that you go through the entire 55,000 books, then you identify what you need? Of course, we never do that one. Because we being human beings, we have our rationale to apply. We will never keep the books like this, but I am just mentioning to you so that you understand. Instead, if you arrange the books, in such a way, you classify the books, based on some parameters like, novels, technology books, business. Like this you classify and then put your books in the respective. This is what this shelf has got only the technology books, or these two shelves has got technology books, something like that. Instead of you searching for your entire 55,000 books to find out you're required, you'll be searching only in a confined, maybe a technology specific rack or a shelf. Only in that you're going to search, not the entire 55,000. This is what is known to you even at your very young age, I mean at your childhood itself. The same when you come to this one, instead of you pushing your entire data into the table, because select star from student is the least used query in the entire lifetime of the student table. Of course, you as a programmer in the beginning, you always be tempted to work with select star from student kind of thing. But in the production environment, select star from so-and-so table is almost, I can say, zero. We will not use that query anytime as part of your Hadoop cluster. We never do that. One second, friends. Really? So select star from student is the least used query in the entire life cycle or lifetime of the table. most of the time we will be using select specific columns, maybe call one like this from the student table, where we use some condition, usually the complex conditions we use to retrieve the data. So when you are trying to retrieve the data based on the columns, conditions and all, we analyze based on which column we actually we query the table most of the times, and that column or those columns will be taking into consideration for partitioning your data. Now here what I said, you are based on your interest how you are taking the parameters to classify your books. Same like based on which columns you are going to query most of the times, based on those columns, maybe column or columns, you are going to partition this table so that instead of we storing the entire data under one, so say for example, all class 1 student data into one partition. Imagine here, if I take my STD as a partition column, then how many partitions we get here? 10 partitions we get, and into each partition the corresponding data will be there. So if most of the times when you are querying the data using your STD, then I will be partitioning my student table based on STD so that the data goes and sits in the respective. Are you getting my point, friends? What I'm trying to share with you here? Are you able to understand what I'm saying here, friends?
Yeah. Yes, sure.
So we are going to partition. I mean, in the other way I say like this. Because as I'm showing you the file system for every time when I'm creating a data set and all. Now if you go and see your slash tmp slash sandbox slash student, and in that if you see, now your entire student data is available in one file. Now instead observe here, inside the same student table, observe closely. I will be having 10 subdirectories. Observe very closely, friends. I will be having 10 subdirectories. Each subdirectory named with that standard. I think you are getting my point. STD equals to your C1, STD equals to C2, STD equals to C3. Like that we will get 10 subdirectories, each subdirectory named with the unique value of the standard. Hope you are getting the point what I am sharing here. So your data will go and sit in the specific subdirectory that belongs to standard 1. While querying, instead of me querying the entire data set, I will be querying only a portion of the data set. Then my querying is going to be more efficient. That is what we technically call it to be partitioning. Which is going to be done at the time of creating the table itself. Let me do that for you. At the time of creating the table itself. So what is that? Why it is so slow today, the system? Look at this one. Create a table if not exists. The table name with the database prefix. Partitioned by the column and the data type. Partitioned by. I hope you are getting the point what I'm showing you here. Partitioned by. Partitioned by. Now what happens with that? What happens with that? What happens with that, friends? What happens with that? Create table name, whatever you are specifying here, partitioned by. The same thing what we did before. What we did before? Create table. Let me do that one here. Vi probably student.hql. Oh, it doesn't have, right? No problem. Vi student underscore pt.hql. Okay. What is that we do here? Create a table if not exists. What is that? Student underscore pt. What is that we do here? Name, which is of type string. What is the other one? Lang1 int, lang2 int, lang3 int, maths int, science int, social int. Getting my point? Now, how we need to specify here?
So partition by int data type.
Didn't get you. Come out again.
So we can use that partition by data type. One is string and one is going to be integer.
Yes. Partitioned by, what is that? std, which is string type. You agree with my point?
Yeah.
Right? Now, partitioned by std, which is a string type. I specify this one. So with this, what is going to happen? With this, what is going to happen?
Take only that string data type data.
One second. If not exists with the name techiebees dot student, so that there will not be any ambiguity. WQ not. So Hive hyphen F student underscore pt.hql. Here show tables I think you got values underscore temp underscore table underscore one. I don't know whether you noticed this or not. When this got created, I don't know whether you got any meaning for this or not. So describe table values underscore tmp underscore table underscore one. Or directly I give so you will not be able to use that one. What is that? Any problem? Missing end of the file partition. Where? Get student underscore pt dot hql. Create table if not exist. Keybase dot student underscore pt. Name lang1, lang2, lang3, maths, science, social.
Partition. Yeah, spelling of partition is
Oh, typo. Right?
yeah, that's good.
So here we say now. So we were discussing something just before. Yeah, here. Sorry. So the table got created as an impact of your insert. Insert into student values and all you said, right? That time this temporary table is being used internally and that you will not be able to use it. You got the point what I am showing there. We have used before, right? Insert activity. So in that context, it is going to internally make use of that one, and that will not be. Now you say describe a student, you will be getting the description for that. And now here show tables I say, we got student underscore PT also. We say describe student underscore PT, you will get this one. But what is the additional thing that we got? Name, lang1, lang2, lang3, math, science, social. STD is also a part of the table definition of the column. This also, but specifically it is mentioning partition information, column name is STD, data type is string. And if you go for describe extended, what is that? Student underscore PT, if you say, you will be seeing table type is managed table, partitioned keys. Earlier it was empty or null, there was nothing here, but now it is saying partition keys, name std, type is string. I hope you are getting the point what I am showing you here, friends. That is why every action that you perform against this one, I wish you to execute. I wish you to do this one so that you will be getting the precise information. You will be getting the precise information. Make sense, friends?
Yeah.
Now, how you are going to load the data into this partition table? How you are going to load the data into this partition table? How you are going to load the data into this partition table? That is important for us. How you load. How you are going to load the data into this partition table. This is an important because it is not like your traditional loading. Load data local in path will not work out anymore. Why? Are you getting my point, friends, here? Are you clear with whatever I am discussing? That is why I requested you to please go through the SQL stuff in the last session. To go through that one, insert overwrite table student underscore PT partition std select. Please look at this one very carefully, friends. Name comma lang1 comma lang2 comma lang3 comma maths science comma social comma std from student. Have a very close look at this one. Why I am compelled to write so long, that also you will be able to understand. Very clearly, it is not complaining that it is not possible. Semantic exception. Dynamic partition strict mode requires at least one static partition column. To turn this off, set hive.exec.dynamic partition.mode equals to non-strict. Non-strict. Set hive.exec.dynamic.partition equals to true. This is one thing I am setting. Same thing. Dot mode equals to non-strict. You may ask me one thing, friends. Srinivas, why we are doing this one? Is for the reason, by default, the dynamic partitioning on your Hive is kept in the disable mode. Because why this is been done? By default, the dynamic partition is set to be in the disable mode on Hive for the reason, suppose you are working on a data set where the partitioned column, whatever the partitioned column that you have, that partitioned column, imagine if it is a primary key, my intention of saying this primary key is, it is having unique values. That is what my intention of saying primary key. At Hive level, we never has got any aspect of primary key, but if that column has got unique values, and if that data set has got 5 billion records, assume. Then tell me, based on that column, if I am going to partition, how many partitions I get? How many partitions I get? How many partitions I get, friends?
5 billion.
Then your name node is going to die, because you know very well that every partition at your Hive level is nothing but a subdirectory. I am going to show you now. Student underscore PT is a table. This is empty as of now. Now I am running the query here, the same query what I did before. Have a look at this one. What is that? Invalid table alias or column reference. Oh my God. The typo again. Okay. See, the complaint this time is different. That is semantic exception, invalid table alias. Now let us observe. Don't come to immediate conclusions, friends. What is partitioning and what is advantage of partitioning? I have explained you theoretically. Now I'm showing you practically with partitioning what is happening and why this partitioning, dynamic partitioning is said to be in the disabled mode. That also we have seen and we have enabled it. After enabling it, the query is running and pushing the data into your partitioned table. When the data is pushing into the partition table, what is happening at the physical level, that also we are trying to see. Let this happen, then we'll be able to see how the data is being pushed into the, what has happened physically at your file system level. What has happened physically at your file system level. That if you are able to get the clarity, then you understand, oh, partitioning means this one. And why the dynamic partitioning is set to be default offer, you will have a clarity on your own. I need not explain you, and you need not remember theoretically, oh, this is the reason why the dynamic partitioning is set to be in the disabled mode. We really don't know what has happened, but happening, it's going on. It's going on, done. And let me also see here, select a star from student underscore PT. Comfortably got 34 records. Comfortably got 34 records, which means the data is loaded into your partition table. See here, friends. Underscore PT I'm using, not your student. Underscore PT. Underscore PT is a partition table. Right? Now you go to the physical level and see here. You'll be able to understand. Inside your student underscore PT, see what has happened. Inside your student underscore PT directory, there are 10 subdirectories created, each with the name std equal to C1, std equal to C10, C2, C3, C4 like that. All your data belonging to class 1 is kept inside this file. So whenever you say here select a star from student underscore PT, where std equals to C1, if you say like this, now from where it goes and fetch the data, it goes and fetch the data from only this particular. It will not go across your data set. I think you got my point, friends. what is the advantage of partitioning. And now I explained you just before why your dynamic partitioning is set to be in the disable mode. Suppose if you are using the partitioned column as a column which has got unique values and 5 billion records, if that column is used as a partitioned column, then how many subdirectories will be created here? How many subdirectories will be created here, friends? 5 billion subdirectories. You know very well that every file system modification is tracked by your name node. 5 billion entries needs to be held by your name node. Your name node will die. Because I have given the metrics, all your file system, the entire file system, HDFS file system will be in the control of your name node. Every structural change you are making to your file system is being noted by your name node. So when name node need to remember 5 billion details, then your name node memory and resources will not be sufficient. It will be down. That is the reason why by default we keep it in the disable mode. Whenever you want, you need to enable it. That time you need to be careful. So in order to protect from the accidental creation of so many subdirectories on a data set whose column has got a very unique values, and in order to protect from that kind of episodic situations, I keep my partition, dynamic partition in the disable mode. So who has created the partitions here? Did I created the partitions here? Did I created the partitions here? All these partitions are dynamically created at the time of loading the data into my table. It is reading. See, what is the query that I am using here? What is the query I am using? From student table I am loading the data. So from student table it fetches the first record and it identifies what is the STD value there. If STD value is already existing in the partition table with STD equal to C1, if that record belongs to C1, then into the same subdirectory it will push that record. Suppose if that with that name, if there is no partition available, it creates a partition with that name and then push that record into that partition. So I hope you are following with me what I am sharing with you here to make this a meaningful one. You understand what we mean by partitioning, and this is what we call it to be dynamic partitioning. But static partitioning, we have one more thing called static partitioning. What we do in the static partitioning is we already need to have a data set. We need to have a data set in such a way that it will have only name, 6 marks, that's it. And that data set is confined to a particular class. Then we physically move the data set into the predefined location under the partition table, so we will not have any problem. So that is called static partitioning. Static partitioning means we are deciding where to move this data set into your partition table. We ourselves deciding that one. But whereas here, the partitions are created dynamically during your data loading. Hope you are getting the point what I am sharing, friends. Now suppose into the same table, if I need to push the data set which is specific to class 10. So in that data set, I need to have only the name and the 6 marks. No STD should be there. Then if I have my data set available like that, then probably I'll be pushing into the direct subdirectory of this one. I can push directly over here. That is what we call it to be static partitioning. So static partitioning, there is no harm because we are intentionally loading the data set into the specific subdirectory. So will not be a problem. But when it comes to the dynamic partitioning only, we have the problem. Not the problem. It may create episodic situations. To overcome that one, they have kept this dynamic partitioning mode in the disable mode. And whenever you want to enable it, use it, and revert it back so that it's not going to create any harm. This makes sense, friends? This makes sense?
Srinivas, I have one quick question.
Yeah, please.
My question is like, instead of the partition also we can directly in the query itself we can give like where std is equals to c1, so it will get all the c1
Yes,
rows,
yes,
right?
yes. No doubt, no doubt.
So
Even
what is the point
in
of
the
partitioning?
a select star from student where std equals to, I can specify c1 here. I'll be able to get the I'll be able to get the data, but see what is
Uh-huh.
happening here. You see what is happening here.
So is it Srinivas, like in this case where we use the where clause, there is a full table scan, and when there is partition, there is no full table scan. Is that the difference?
Obviously, I think you noticed here, select star from student underscore PT, where std equal to c1 I have given, I directly got the data, but here you see, same, on a non-partition table, select star from student, where std equal to c1 I said, then a MapReduce job is running for you in the background, and it needs to scan the entire table, and I mean, entire table in the sense, in the background, entire data set basically. And from that entire data set, it should fetch where all std is matched with c1, only those records needs to be fetched. Then it is going to be a time consuming process. You are noticing and you are witnessing that one here, you yourself seeing with your own eyes. The same on a partition table, I said, Sri, I think you can understand from this one. Select a star from student underscore PT, where std equal to c1 I said, I got the answer immediately. Whereas select
Yeah.
star from student where std equal to, here I am getting the data from a non-partition table where std equal to c1, the same query, but you see how much time it is taking. But ultimately the output from both the same. Output is the same. You notice that one? 2,
Yeah.
4, 5 records you got. Here also 2, 4, 5 records you got. Kishore, Kasim, Rahul, Suman, Sagar. Here also you got the same. But you see in terms of read writes that are happening at your background. The read writes
So
that are happening.
student underscore pt is a partition table then.
Yeah, that is what we created, right?
Yeah, yeah. Okay.
So that is
Yeah,
what
okay,
we
okay.
created. We created the student underscore PT table. Student underscore PT is a partition table. You see here describe student. It says this one. So describe student underscore PT. You see this one. This is a partition. STD is a partition column. Whereas in the normal table, all are a part of your table definition itself.
Okay,
So
okay.
PT is a table, but you need to understand here, this STD is also a column, but that is a partitioned column. So to make you to understand clearly, I have taken you to the file system level and made you to understand when you are doing partitioning, what is happening at the grassroots level, so that you will be able to visualize. That is the reason why I have taken you to this one. So instead of it searching the entire data set now, it is going to only work with this small data set. I also can keep the condition here. Select a star from student underscore PT where std equals to c1 and maths greater than 80 AU. You see here what is happening now. Even if it is a partition, still it is running a MapReduce job, but this MapReduce job is going to work against the data present only in that specific partition, not your, it is not going to scan your entire data set. You may ask me one thing, Srinivas, why it is taking so much time even to query a small data set here? If it is a case of a huge data set, then it may take hours together. No. As I told you, the basic, basic need. What is the basic need? Here, your query needs to be translated into a MapReduce job, and a jar file needs to be created. That needs to be submitted to your cluster. This headache will be there either with a small data set or a huge data set. So then only your mapper and reducer activity will come into picture after the jar file is submitted to the cluster. So that override will be common irrespective of the data set. Now once that starts, your mapper phase and the reduce phase, that activity starts. Let it be one GB data set or 1 TB data set or 1 petabyte data set. More or less it is going to take the same time to process your data set. Hope you got the
So
understanding.
yeah, so in this case, that STD is equals to C1, it considers that as one set.
Yeah, I mean, see, we should not treat like that, but to make you to understand, I have taken you to that level. I mean, we can treat this as a sub data set because
Sub
your
okay.
student is the actual data set to us, but truly speaking, this STD equal to C1 has got one data set which has confined only to C1. But as at the student table, we are considering it to be data set. We call this as a sub data set. But we should not think at that level, honestly. The only for your understanding that I have shown you the file system that is getting created for every of your action. But we should not, talk at that level anytime, because when you're talking about Hive, we only talk in terms of the tables, not in terms of the files in the background, directories and subdirectories in the background, because that will not make much sense. That is all for our understanding. So we only need to talk about partition, that's it. It's a partitioned, in a partition table, your data is, only specific data is stored in a specific partition, so that my querying is going to be faster. I need to talk like that only. But how it is, how the efficiency is coming, that we can understand looking at the background details. But while talking, we only need to talk in terms of the table, partition column, like that only we need to talk.
Okay, got it, Shiva.
So this is a very detailed and I know very deeper level, because I know Hive is definitely important. That is the reason why I have taken up this one. You can see here hive.exec.dynamic.partition is set to true. Okay. And hive.exec.dynamic.partition.mode. It is by default in the strict mode. We need to make it non-strict. Dynamic partitions per node and dynamic partitions, max.created files, and hive.error on empty partition. So we need to alter these properties to make your Hive to work as expected, right? So look into this one, friends, then you will be able to understand how your dynamic partitioning can be achieved and how you can load the data. Now my next question is, now instead of you keeping your entire data set as a single, that is what we noticed. What we are doing now, we are cutting the data set and pushing into the respective directories or subdirectories and all that stuff. Now I ask you, within that partition, now this is your std equals to C1. Now all your C1 data I will push here. Now if this also grows bigger, then what you will be doing? You got my point? When your data set grows big, then your querying is going to be tough. That is why we are partitioning it. The data pertaining to each partition, if that is also growing huge over a period of time, then what will you be doing? Are you going to do subpartitioning? I mean, the same thing, whatever you are seeing here, this you are going to do it as, like this you are going to do. The answer is yes. That subpartitioning is what we technically call it to be bucketing. So when this partition grows big, or when this partition starts getting increased, the size, then again the same old bottleneck is going to be raised. What is a bottleneck? Querying becomes slow. In order to retain that query performance, we are going to do bucketing. So instead of you storing the entire partition data in single shot, we are going to store that data into different buckets. And how you achieve that one? You are going to achieve this bucketing. At the time of table creation itself, we are going to specify. That is where you have data definition. At the data definition time only, we are going to specify. Instead of we creating the table, just a partition table, because we know very well we are essentially dealing with huge data. So at the time of creating the table itself, we are going to specify the buckets that I need. I think you see here, partitioned by so and so column, clustered by, and into buckets. I think you are seeing at the time of table creation itself, we are going to specify along with partitioned by, we are also going to specify clustered by, and into whatever the buckets. Clustered by, we are going to specify the columns that are going to be used for clustering, and that is what we call it to be the buckets actually. You see that that syntax. Of course, with this small data set, it will not make sense to say clustered by so and so columns. I think you are seeing sorted by into number of buckets. Getting my point, friends, what I'm sharing with you here? Are you able to understand the concept? Hello?
Yeah, so you mean like the bucket size, you're going to fix it prior, it's not dynamic?
Not size here. That is where mistaken. That is the reason why I'm asking you specifically. Got the point. We are not going to specify the bucket size there. Instead, we are going to specify the number of buckets. Now, I give you an example. Say if I am going to store my student data into 10 partitions, and here I'm going to specify the number of buckets to be 26 with the intention that inside this one, I mean, at the time of giving this 26, my intention is clustered by name. Name column I use as clustered by, so that 26 I give. I think you understand what I mean by the 26. All the names that starts with A will be into one bucket. Starts with B into one more bucket. Starts with C into one more bucket. D into one bucket, something like that. Because I used name there. I think you are getting the point what I'm sharing here.
Yeah.
Friends, if you are able to follow or you are thinking about this aspect, that is fine. If you are not able to follow, if you let me know now itself, I get the chance to explain you. Otherwise, it will be tough for me to handle. So why we do bucketing is for the reason, if my partition itself is growing huge, then the same old aspect of performance bottleneck will arise again. So as a result, we are going to face a challenge. Now, in order to resolve that, because when we are talking about big data, essentially we are talking about huge data sets. So at the time of table creation itself, we are going to take this care. And for that sake, what is that we are doing? We are using this one. What is that we are using? We are using, in terms of the table creation, we are specifying clustered by the column, and we are going to specify clustered by, and we are going to specify that column and into number of buckets, into 32 buckets, I assume 32 buckets, I say 26 buckets, 40 buckets. So within the partition, those many buckets will be there. I don't call it as a sub partition, I call it as a bucket. So that is how I am going to do it. So the intention of even dealing that concept today itself is to give you buffer time so that you can do your own R&D in getting your things done. So please look into this concept, friends, and try experimenting. If you have any questions, don't hesitate to bring it to my notice. I'll help you out in understanding the concepts. Any questions to me for today? So if no questions, we end up at this level. I'll catch up again in the next session, friends. Great time ahead.
Thanks, Srinivas.